going on, guys? Let's look at this problem right here. This question is asking find the solution of the given initial value problem, and here we have a differential equation, and that is matching with this pattern. This is a linear second order differential equation with constant coefficient, and when we have linear differential equation with constant coefficient, we can use this characteristic equation to find out our real roots. Now, since this is also linear second order differential equation with constant coefficient, we can apply this one. Let's figure out our ABC value. Here A value is going to be this one, 4, and B is -8, and C is 3. And after we find that one out, we can plug it in this equation. This is going to be 4r square plus B is going to be -8. So that's going to be -8r plus 3 is equal to 0. And if you factor this one, you will get 2r minus 1 times 2r minus 3, that's equal to 0. Okay, now from this one we can find our r values. The first one is going to be 2r minus 1 is equal to 0, therefore let's write that one down. 2r minus 1 is equal to 0, therefore r is going to be 1 over 2. Let's say this is r1, and this is going to be r2, that's going to be 3 by 2. Since we are having distinct real roots, the general solution of this differential equation is going to be in this pattern, right? Now let's go ahead and plug it in this equation. So the general solution is going to be y of x is equal to c1 e power r1. r1 is half, so half x, and plus c2 e power r2 is going to be 3 by 2 x. Okay, this is the general solution for this differential equation. Now, since we have the initial values, we have to find the particular solution. To find the particular solution, what we do is we substitute these values and find out what is the C1 and C2 values. Then we plug it back in this general solution, and that's going to be the particular solution. Now, let's see what we get if we plug 0. So, and we know that y of 0 is equal to 2, and if we plug 0 for x values, this is going to be c1 e power 0, because half times 0, that's going to be 0, and then plus c2 e power 0 again, because 3 by 2 times 0, that's going to be 0. And from this one we can see that c1 plus c2 is equal to 2, so 2 is equal to c1 plus c2. Since we have two unknown variables, we cannot do anything. Now let's try to find a derivative of this one, okay, because we can substitute this one too. Now if we find the derivative of this one, this is going to be half, okay, y prime of x is going to be half c1 e power half x, and here we are going to have 3 by 2 c2 e power 3 by 2 x. Okay, this is the derivative. Now let's see what we have. Here we have y prime of 0 is equal to half. Now if you plug 0 for these x values, again you will get, this is half, right? Half is equal to, this is going to be half c1 plus 3 by 2 c2. 3 by 2 c2 is equal to half. Now to get rid of this 2, we can multiply everything by 2. In that way we will get, so let's say this is equation 1. In this equation we can multiply everything by 2. That way we will get 1 is equal to c1 plus 3c2. And now let's say this is equation 2. And from this one you can see that we can get rid of this c1 by substituting, like subtracting each other. Let's subtract and see what we get. So 1 minus 2, 1 is 2 is equal to c1 plus c2, 2 is 1 c1 plus 3c2, and if you subtract, this is going to be 2 minus 1, that's going to be 1, this is going to be 0, and c2 minus 3c2, that's going to be -2c2, therefore c2 is going to be equal to -half. Now we found out the c2 value. Now we can find the c1 value. To find c1 value, what we can do is we can plug it in this equation and see what we get. So c1 is going to be 2 minus c2, 2 minus half, and that's going to give us 2 plus half, that's 2.5, that is equal to 5 over 2. Okay, this is our c1 value. c1 is equal to 5 over 2. Now we have the C1 and C2 values. Now we can write our particular solution for this differential equation. Now to write this one, let's get rid of this part. Okay, let's get rid of this and let's write this one right here. Okay, here we are going to have y of x is equal to, I'm just copying this general solution, and the only thing I'm going to change is the C1 and C2 values. I'm going to plug this one, and this is going to be 5/2 e power half x plus C2 is negative half, so this is going to be negative half e power 3/2 x, and that's going to be the particular solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.